All right, today we are going to start section 19.2, which is transforming quadratic functions, and today will be part 1. All right, our essential question is how are we going to get a graph of something like g of x equals a times x minus h squared plus k from the graph of the parent function f of x equals x squared. So if you remember back, I know it's been a long time, but if you remember back to when we looked at the absolute value functions, we had a very similar setup where we had this x minus h and we had this plus k. And what those two things did was they shifted or they transformed our absolute value function by moving it over to the left or right and up or down. So this is a similar idea to that. And we already looked last week at what effect A would have, whether it stretched it, made it skinnier, or whether it shrunk it and made it wider. So as we get going on this, remember this is what we are going to call the vertex form. Where it has an A, an H, and a K. Those are just going to be numbers when you get into actual graphing of these. They're just a constant number. So each quadratic can be represented in this form. And we are going to look at how those will change from the parent function. And eventually our ultimate goal is to be able to graph this by doing some transformations and another process that'll make it quick and easy. All right, explain 1. We are going to look at vertical translations. This moves it up or down. So it's whatever is added at the end, it moves it up that number of units. If it's subtracted at the end, it's moved that many units down. So we are going to graph the functions. We are going to give the minimums or maximums, and then we are going to show the axis of symmetry. All right, example 1. So this one's already been done for you. You know how to plug in numbers for x and get output value. So -3, when we plug that into x squared, remember the parentheses, we end up getting 9, and repeat the process. We did this part yesterday. I'm going to graph this one in green. So when we look at this, our parent function, it does have an axis of symmetry. It should look the same on either side of that line of the y-axis, or where x is equal to 0. Now I'm going to graph the x squared plus 2. So essentially what this is going to do, I'm going to do this one in red, but we're going to do the x squared. So -3 squared plus 2, so 9 plus 2 makes 11. Essentially, if you take the x squared table and just add 2 to every value, you'll get what we have in this section right here. So I'm going to graph this one, and then we're going to compare it to the parent function. Okay, I redrew my graph a little bit, but if you notice our new function, when we added 2, it shifted everything up 2 points. So it just moved that whole graph up 2. Our new one now has a minimum of 2. The lowest it can be is 2. And the axis of symmetry is still x equals 0. It's still that y-axis because it still looks the same on both sides of the y-axis. All right. Example 2. We are going to do it again with the next function, and we already know the x squared value, so I'll just write them in. All right, this time to get our g of x, or our new outputs, we do the x squared and then subtract 5. So in this case, instead of it being 9, it'd be -3 squared, which is 9, minus 5 gives us 4. 4 minus 5 is -1. -1 minus 5 is -4. 0 minus 5 is -5. 1 minus 5 is negative 4. 1 and 9 minus 5 is 4. So we should still have that repeating pattern. We still have 4, negative 1, negative 4, negative 5 at the vertex. Then it repeats negative 4, 1, and 4. So it should still do that same thing when you go through and calculate this. I'm going to plot these two and then you can see the difference. Okay, so if you notice, our new graph are shifted down. It has a minimum of negative 5. That's the lowest it can go. And the line of symmetry, it still looks the same on both sides. It's still x equals 0 or the y-axis. All right. We have a your turn, so go ahead and try this one. I'm going to pause it. You can sketch this out and just see how it goes. If it helps you, create a little XY table. And we'll do the same numbers, negative 3, negative 2, negative 1, 0, 1, 2, and 3. So try it, graph it, and then check it in a little bit. Actually cross off the negative 3 and the 3 and just go negative 2, negative 1, 0, 1, and... Okay, so you can see the answers here. If we take negative 2 and square it is 4, plus 4 gives us 8. Repeat the process, 8, 5, 4, 5, and 8. It does have a repeating pattern. Plot your points. It should look something like this. With an axis of symmetry, it looks the same on both sides of that x equals 0. The minimum of this one is now 4. Okay, one more for you to practice. So again, you can try this and sketch this out. If you want to make the table, if you do your x and your y, again, let's do negative 2, negative 1, 0, 1, and 2. And pause it, try it, check it back in a little bit. Okay, so you can check your answers, put in your numbers, square them, and then subtract 7. You should get those values for y. When you graph it, it should look like this. It looks like it has been shifted down 7 units. It has a minimum now of negative 7, and the axis of symmetry is now x equals 0. So our next step, we are going to look at the idea of moving it left or right, or horizontal translation. So a horizontal translation is that when we have something inside the parentheses with an x. So x minus h, be careful, it's that x minus h squared. The negative does not go with the h. If h is greater than 0, so if it was 2, it would move it 2 units to the right, slide everything over. If h was a negative 2, so x plus 2, so if we have x minus 2 squared, h equals 2. If we have x plus 2 squared, we can rewrite that as x minus negative 2 squared, so h now is negative 2. This would move it 2 units to the left. So let's look at our example. We're going to graph the functions. We're going to give a minimum or maximum and an axis of symmetry. So the idea here, I'm going to again do the parent function in green. It's already been calculated. And then I'm going to go through the process of doing the x minus 1 squared, and we'll graph that. So for this one, if we look at negative 3, we put in negative 3 minus 1 and then square it. So negative 3 minus 1 is negative 4. Negative 4 squared is 16. Do the same with negative 2 minus 1 squared. That gives us negative 3 squared, which is 9. Negative 1 minus 1 squared. This is where you have to be careful with adding or subtracting negatives. Negative 1 minus 1 is negative 2. Negative 2 squared is 4. 0 minus 1 squared is going to be negative 1 squared, which makes it 1. When we have negative 1 minus 1, or sorry, make that positive 1, then square it, that's 0 squared, so that's 0. And 2 minus 1 squared is 1 squared, which is 1. And 3 minus 1 squared is 2. Square that, and that's 4. So I'm going to graph these, and we will see what that did. Okay, when you graph those, you should see that it shifted that whole graph 1 to the right. So h equals 1 in this case. It moves everything 1 space to the right. Now we have an axis of symmetry. Our axis of symmetry now is x equals 1, and we still have a minimum of 0. So it can't go below 0 still on this. All right, let's look at that next example. Now we have an x plus 1 in the middle. Remember, h is going to be the opposite of, essentially the opposite of whatever is in here. So h is opposite of this. So in this case, h is negative 1, because we could do x minus negative 1 squared. All right, so that h value is, it's x, always x minus h, so the h value is negative 1. All right, so if we plug these in and square them, negative 3 plus 1 squared gives me negative 2 squared, which is 4. Negative 2 plus 1 squared is negative 1. Square it, makes 1. Negative 1 plus 1 squared gives me 0 squared, which is 0. 0 plus 1 squared is 1 squared is 1. 1 plus 1 squared is 2 squared, which is 4. 2 plus 1 squared is 3 squared, which is 9. And 3 plus 1 squared is 4 squared, which is 16. All right, I'm going to plot these, and we will look at them and find our minimum and. All right, so we can find our axis of symmetry and our minimum. It shifted everything to the left 1. Our axis of symmetry now is here at x equals 1. So axis of symmetry is x, sorry, that's negative 1. X equals negative 1. Our minimum, the lowest it can go, is still 0. All right. So now we have a couple more that you can do as practice. So pause the your turns, make a quick table. If you pause it, try them, sketch them out, and then I'll go over them in a minute. Okay, when you go to graph these, I want you to use these values for finding your table, if you're going to make a table. Or you can just use the idea of how it's going to shift and sketch it that way. I will go over why we chose these values in our next lesson, but it's based off of where I know the vertex will be. Okay, so if we look at them, we'll see that we end up getting our repeating pattern in the table, and we plot our points. Find the axis of symmetry is now 2. Everything got shifted over to the right 2. We can see that it means right 2. All right, if we look at this one, it goes left 3. So we can look at our table, and I should have actually went to -5 and not have the 0 in there, but we get a repeating pattern 1 0 1. If we went -5, it would be 4, and if we went -6, it would be 9 to repeat that pattern. So the other way you can do it is, since we know that this will shift at left 3, we can just redraw the graph of a parabola and move it over 3 spaces. All right, you do have a homework assignment that I want you to work through and submit it as soon as you can.